Right, in this video we're just going to do a few practice problems to get ready for the test on sections 1.4 and 1.5. That's solving quadratic equations and imaginary numbers. So here in problem number 1, use any method to solve this quadratic. And the first thing I notice is it's kind of out of order, so let's put it in proper order. Negative 2x squared plus 1x plus 15 is equal to 0. And if we try to factor this, old-fashioned, figure out the numbers, it'd be 2x and x, the factors of 15. No matter what we try there, it's not going to work. So we're either going to need to do complete the square or quadratic formula. And remember, our quadratic formula is x is negative b plus and minus square root of b squared minus 4ac all over 2a. I'm more partial to myself to completing the square. So I think I'm going to attack this one by completing the square. We can't complete the square until our leading coefficient is positive 1. So I'm going to divide everything by a negative 2. So these will cancel, and I'll have x squared plus a negative half x is minus 1/2 x. And then we'll have this negative overpower the positive, and that'll be minus 15 halves. And we'll leave that as 15 halves. Okay, move this up. And I want to get that negative 15 halves to the other side to leave myself my little opening. So x squared minus a half x, leave a gap. 15 halves jumps over here and becomes a positive 15 halves. And now I know this is going to set up and become a perfect binomial squared. So we bring down the x, we bring down the sign, and we want to chop this fraction in half and bring it down. We either chop the numerator in half or double the denominator. And since our numerator is already a 1, we'd chop that in half to another fraction or a 0.5. Let's just double the denominator, 1/4. So to figure out what we add to both sides, we square that. 1/4 squared is 1/16. So we're going to add 1/16 to both sides. And let's see here. I'll probably need my calculator on this. I want to get a common denominator there on the right hand side. So to get this denominator to match 16, I'm going to multiply by 8. 15 times 8 is 1/20/16. So 1/20/16. And this is a plus. And then we can add those together and get 121/16. Now that looks pretty nasty as a fraction, but remember we still have our most important step where we square root both sides. And when I look at the numerator, that's a perfect square, and my denominator is also a perfect square. So the square and the square root on the left side cancel, and we're left with what is under the radical, x minus 1/4. That is equal to the square root of 121 is 11, and the square root of 16 is 4. Alrighty. And now, plus or minus. Don't forget when we square root that, we have a positive and negative root. So, and the game's not over till x is by itself, so we're going to add 1/4 to each side. So now it's a positive 1/4 plus and minus 11/4. And we could put that all over one denominator 4. 1 plus or minus. Remember, these are always two separate solutions. And here, this isn't too bad a one. There's no square root left in this answer, so let's find them both. 1 plus 11 is 12/4. And the other one is 1 minus 11 would be negative 10/4. And 12 divided by 4, that's just a nice 3. And our other answer, negative 10/4, would reduce to negative 5/2. So there's our two solutions to the original problem. You'd also get those same answers if you use the quadratic formula. Because remember, the quadratic formula is created by completing the square. Number 2 is a little easier. We want to solve that for x. And notice we only have an x squared term. There is no x term. So we will extract the square roots. First step, get x squared alone. When we divide here by 3, we will get x squared equals 6 divided by 3 is 2. So we have our squared term isolated, square root both sides, x is going to equal the positive and negative square roots of 2. Number 3. Now it's a quantity squared. X plus 13 quantity squared equals 25. Well, our squared term, even though it's a binomial, is isolated, so square root both sides. On the left, the square and square root cancels. We're left with what is under the radical, x plus 13. That's equal to the square root of 25 is 5, plus and minus. And then, of course, we're going to get x alone by subtracting 13. Negative 13 plus and minus 5. You know, this, as it's written, it's two answers in one. Let's separate them. Negative 13 plus 5 would be negative 8, and negative 13 minus 5 would be negative 18. There's our two solutions. Let's see here, number 4. X squared plus 12x equals negative 25. Of course, the first thing I want to do is get everything on one side, so I'll add 25 to both sides. And I could, think about this. Okay, x squared has to be x and x. The factors of 25 would be 5 and 5, or 1 and 25. And there's no way we're getting that middle term of 12x. Let's see. Last time we did complete the square, so let's do a quadratic formula on this. Let's figure out our a, b, and c. A is the number in front of x squared, b is in front of x, and c is our constant. So in front of the x squared is a 1. In front of the x is a positive 12, and in front of the our constant is just positive 25. So there's a, b, and c. Quadratic is x equals negative b, so that's going to be a negative 12, plus and minus the square root of b squared, 12 squared is 144, minus 4 times a times c. A times c is 1 times 25, or 25. And that's all divided by 2 times a, or 2 times 1. So, let's simplify, starting with under the radical. Negative 12 plus minus. We have our square root. 144 minus 4 times 25. Well, if you have 4 quarters, that's 100 pennies or $1. 144 minus 100 is 44, all over 2. That's a good answer. It's not the best. It's not as simplified as we can make it. Under the radical is a 44. Is there a hidden perfect square under the radical? Well, 44 is 4 times 11. 11 is prime. 4 is a perfect square, so we can square root the 4 and bring it out. So we're going to have a negative 12 plus and minus. The square root of 4 will come out as a 2, and then the 11 is stuck under the radical, all divided by 2. Now, we can simplify a little farther. All our coefficients are divisible by 2. So, let's divide all of those by 2. Negative 12 divided by 2 is negative 6, plus and minus. This 2 divided by 2 is 1, so 1 times the square root of 11 is just square root of 11. And the denominator, that 2 will divide out and just be a 1, so we don't need a denominator at all. Negative 6 plus or minus the square root of 11. Okay, now on to the second half of what the test will be, and that's imaginary numbers. This goes usually a little bit better than the quadratic stuff. So here we're just adding a couple imaginary or complex numbers. So since we're adding, there's no negative to distribute. We don't have to worry anything about the sign, so let's just collect the pieces. This real component 7 plus this real component negative 4 comes out to a 3. We have a 5i and a plus 2i. That's plus 7i. 3 plus 7i is our final answer. Now we're going to multiply. FOIL it out. First times first, 21. Outers. 7 times negative 5i is negative 35i. Inners, 2i times 3, and that's a negative, is minus 6i. And then we have negative times negative is positive. 2 times 5 is 10. I times I is I squared. And remember, this I squared is equal to negative 1. And that negative 1 is just going to flip-flop this sign to a negative sign. So what we have now is 21 minus 35i minus 6i minus 10. So let's collect our real components. 21 minus 10 is 11. And then we have minus 35 and another minus 6i. We have minus 41i. Final answer. Number 7, write the complex number in standard form. You know, and always the first thing to address in these problems is the negative under the radical. So we have our 2 minus. When we pull that negative out, it's going to come out as an imaginary component, and then we have our 27. Can we simplify that 27? What perfect square is hidden in 27? Well, 27 is 9 times 3. And we can break that up into separate radicals. So we have 2 minus. This 9 is a perfect square. The square root of 9 is 3, so we're going to have 3i. And then we have a 3 trapped under the square root. All right, number 8, write the quotient in standard form. Remember, standard form it's sort of like rationalizing. When we rationalize a denominator, there's no radicals left in it. When we rationalize this quotient, we want to get rid of the imaginary numbers. So we're going to multiply the numerator and denominator by the conjugate of that denominator. What's the conjugate of 5 minus i? Well, of course, it's 5 plus i. 5 plus i in the numerator, too. So our numerator, let's see, for now, let's just leave it as 5 plus i times 5 plus i. And our denominator, you know, if we FOIL this out, the inner and outer terms will disappear. So we do first term times first term is 5 times 5, 25. Negative times positive is always negative. And then we have I times I is I squared. And I squared is equal to negative 1. So let's see, I'm going to slide this over. Let's move this over here. And let's FOIL out the numerator first. 5 times 5 is 25. And then we're going to have a plus 5i and another plus 5i from the outers and the inners. So that's going to be plus 10i. And then plus I times I is I squared. In the denominator, and let's just leave that as 25 minus I squared now. Because remember, I squared, we can do something with that I squared. I squared is the same thing as negative 1. So this plus I squared is going to become plus a negative 1. And this minus I squared, that I squared is going to be replaced with a negative 1. So, numerator. 25 minus 1 is 24 plus 10i divided by 25 minus a negative 1 is 26. And if we want to go the extra mile, I look at all my numbers, my coefficients are all even. So I know I can at least factor out a 2. Let's take all of the numbers and chop them in half. Half of 24 is 12 plus half of 10 is 5, and there's our I. 26 chopped in half is 13. 13 is prime, 5 is prime. We're not going to reduce that down any farther. And that's the last question. There's only 8 on this practice test, so I hope that gets you ready for the real test tomorrow.